So, with calculus, there's more than just one derivative. You could take the derivative again, and again, and again, and again. For instance, let's say we have y equals x squared plus 3x minus 4. We want to take the derivative. That'd give us y prime equals 2x plus 3. Okay? We could also rewrite that as dy equals 2x plus 3 dx. Well, could we take the derivative of 2x plus 3? Yeah, that would give us d2y equals 2 d2x. Ta-da! Could we take the derivative again? Absolutely we can. We take the derivative again. d3y equals something d3x. Okay, it's just saying what derivative it is. Well, in this case, it would be the 0th derivative. Okay, it would equal 0. The derivative of 2 is 0. Other ways to write these, we could write it as y prime, y prime, y double prime, y triple prime. Anything after triple prime, you'd call it y to the whatever derivative it is. Use the same thing with f of x, f prime of x, f double prime of x, f triple prime of x, f4 x, just telling what derivative it is. Okay? So let's take this back to physics, because in physics is actually a lot of calculus. A lot of you have taken a physics class in one way or another, but you haven't really seen the calculus that's in the physics. Okay? So with physics, you have your distance. Usually they measure it in meters. Okay? So you've gone 20 meters, you've gone 30 meters, you've gone 40 meters. Well, as your distance is, whenever your distance changes, aren't you moving? Okay? You're either moving fast, you're moving slow, but you're moving. All right? When you're moving, they call that meters per second. All right? Hey, that's why this is dy dx. Ooh, it's like a derivative. Speed is a derivative of distance. Okay? Let's take it another level. If we took another derivative, that would give us dy dx. Okay? Over here, this will give us meters per second squared. Oh, hey, what's going on there? Okay? Might say d2y, d2x, meters per second squared. This is acceleration. As you accelerate, doesn't that make you actually go faster or slower? Because there's deceleration, or braking, hitting your brakes. That makes you slow down. Okay? So here's how we can see different levels of derivatives in the real world. You've got your distance traveled. You're traveling to school, 5 miles. On your way there, at some points you're going 5 miles an hour, other points you're going 10 miles an hour. To go from 5 miles an hour to 10 miles an hour, you have to accelerate. That's your acceleration. That would be a second derivative, okay? Then all of a sudden you pull into the school parking lot. Well, you don't hit the gas more and accelerate more. You hit the brake. Okay? All of those are acceleration. All right, let's try this problem. We've got this problem up here, okay? It's f of x, that's kind of like a distance. That's how far you're going to go. Here, it wants us to find the second derivative. It wants us to find the graph that represents the acceleration at any point on the curve, okay? So, we're looking at this. Well, we know how to do this. To take the derivative, to get the first derivative, f prime of x, we do 2 times 3 is 6x plus negative 4x. What's 1 less than negative 2? It's negative 3 plus 2x to the negative 1/2, because 1 less than 1/2 is negative 1/2. So that's our first derivative. We now need the second derivative, f double prime of x. Okay? Well, what's the derivative of 6x? It is 6x to the 0, but isn't x to the 0 just 1? 6 times 1 is just 6, so we don't care about that. Plus We bring the negative 3 down. Negative 3 times negative 4 is 12. X to the 1 less would be negative 4. Plus negative 1/2 times 2 is negative 1. X to the negative, what's 1 less than negative 1/2? Negative 3/2. You might say negative 1 1/2. Technically that's true. Whenever we're working with exponents though, leave it as an improper fraction. Okay, whenever you're dealing with exponents, leave it improper. Because this means, with the negative, if you have x to the negative 3/2 to the negative, means that it's over 1, so it's reciprocated. So it's 1 over x to the 3/2. The 3 is an exponent. The 2 means it's square rooted. So you've got 1 over the square root of x cubed. Okay, that's what that means. So we just leave it as an improper exponent. All right, give this one a quick try. We want to find the fifth derivative of this function, 4x plus 3x to the negative fifth plus 16x to the 3/2. On your mark, get set, go. All right, you should have paused the video. You should have the answer by now. Let's do this. So we want to first find f prime of x, the first derivative. Well, 4 times 1 is 4. But that leaves us x to the 0. Is x to the 0 going to help us at all? No. We just leave off the x to the 0. Plus, negative 5 times 3 is negative 15, x to the negative 6, plus 16 times 3/2. That's going to be 24, x to the 1/2. Okay, so we subtracted 1. All right, let's do the next derivative. F double prime of x. What's the derivative of 4? Well, it's x to the 0. What's 0 times 4? 0. It's nothing. Okay, it's gone. Negative 6 times 15. Ooh, that's going to be a big one. Negative 6 times 15 is positive 90. X to negative 7 plus, let's see here, half of 24 is 12. X to the negative 1/2. We're not done yet. We now need to find f triple prime. Now we got to go all the way to the fifth derivative. We're at the third. We need to do this 2 more times after this. Let's see, 9 times 7 is 63. So we've got negative 630 x to the negative 8th power plus, let's see here, that'd be negative 6x to the negative 3/2 power. Okay. We've got f to the 4th root now of x equals 8 times, I'm going to use a calculator on that one. Could I figure it out? I probably could. Is it right to be lazy sometimes? Absolutely. Let's see, this is going to be positive 5040 x to the negative 9th power plus, divide by 2, that leaves me with 3. 3 times 3 is 9. Positive, so 9x to the negative 4 halves. Oh no, sorry, 5/2 power. All right, last derivative, f to the 5th. Finally, to get the answer, the 5th root of this whole equation. 5040 times 9 is going to give me negative 45,360 x to the negative 10th power minus 9 times 5 is going to be negative 45 over 2 x to the negative 7/2 power. That is the 5th root. Ugh, that was rough. Really wasn't that bad. Okay. But you can see if I ask you for the 10th root, this could take a while. It could definitely take a while. Am I going to ask you for the 10th root? No, I'm not. All right, I want you to go through and try this one real quick, okay? If you're still feeling like you need a little bit of help, go through, give this one a quick try. What do you get? All right, the time is up. If you still need to pause the video, go for it. Here's the answer. So we're looking for the third derivative. So we're going to have dy, d2y, d3y, all right? So 2 times 5/8 is going to be negative 5/4 x. So negative 3 power plus, let's see here, we've got 3 times 3, so that's going to give me 4x squared, plus 4 times 2/3 is going to be 8/3 x to the 4th. Notice I'm just leaving these as fractions. I'm not giving crazy decimals. I'm leaving them as fractions, as improper fractions. And that might be because later on, something's going to work out. Okay. Ooh, actually this should have been 1/3. Plus negative 3 times 1/10, that'll give me negative 3 over 10 x to the negative 4th. Okay? So that's my first derivative. The second derivative now, negative 3 times negative 5 over 4. 3 and 4 don't cancel each other out, so I'm just going to multiply it to the top. That's going to give me 15 over 4x to the negative 4th, plus, see here, that'd be 8x, plus the 2 minus 1 is just 1, so don't bother writing it. 3 times 3 is 8x squared, plus negative 4, ooh, it doesn't go into 10, so I'm just going to do negative 4 times negative 3. Actually, 2 negatives make a positive. I can cancel a 2 out. That's going to give me 6 over 5x to the negative 5th. Okay? Last derivative, here we go. Negative 4 times 4, well 1 over 4, 15 over 4. The 4's cancel out. That gives me negative 15 x to the negative 5th power plus 8 plus 16x plus 5 times 5, it's going to cancel out that 5. Well, 5 times 1 over 5. That's going to give me negative 6 x to the negative 6th power. Okay? If I want to go through and clean this up a little bit, you normally write the exponents from least to greatest. From greatest to least. So technically, we could write this as 16x plus 8 minus 15x to the negative 5th minus 6x to the negative 6th. That would be the correct answer right there.